This is a setup for today's experiment. So we've got a pair of Helmholtz coils. The idea, of course, with Helmholtz coils is that their separation is equal to their radius, so it should create a uniform magnetic field within there. We've got a light detector and a laser emitter. It's going to send a laser beam out. It's going to reflect off a mirror on our magnet onto a detector. So the magnet's going to oscillate, and we're going to measure the period of the oscillations and use that to calculate its strength. We also have a printed circuit board here with the timer on it, so I'm going to set that up just now. So let's work on that. Okay, so easy starting point. I'm going to take the ribbon cable and plug it in. And if you get it right, it should just close like that. We also have a couple of wires. So I'm going to take this extremely chunky old multimeter. Extremely chunky and old is also how I describe myself on my Tinder profile. So what we're going to do, we're going to connect this up. Let me just untangle this cable here. So what we're going to do, we're going to connect this up. So I have a power supply up here, so I'm going to put power through the coils. I've moved the power supply onto the desk so that the cables will reach it. So it's pretty straightforward. We just need to take the power cable, connect it here. The actual order doesn't matter too much, so I'm just going to do it this way. And then I'm going to plug this into the common terminal, so that's my multimeter there, which I'm going to rest just on the bench for a moment. And then obviously I want to measure current, so I'm going to set that there. So I'm into the common and the current terminal. Let's turn this on actually. So we're at about 2 amps, about 9-ish volts. If I turn that on, you can see the reason we use the multimeter. So here you can see why we use our multimeter, just because there's that very slight difference. These power supplies aren't too accurate in the information they convey. Now we do have a negative, and it's pretty easy to fix that. I just need to switch these around, like so. There we go, so the negative sign's gone, the value stays the same, so we're set. Okay, and all I did there was I just changed the direction of the wiring on the common and the 10 amp terminal, so I just switched those two cables over, which you should be able to see. The next part of the experiment is the part I've always found hardest, if I'm being honest, because I have, as you know, the shaky hands. And what we've got at the moment, so this is a thread hanging down, and obviously thread is made of kind of winding individual bits together. So to get rid of the twist from the thread, like the natural torsional twist, we suspend a brass weight from it. So we need to, now that we've had this hanging for a while, we need to replace that brass weight with a magnet. You'll also be able to see maybe just on the brass weight, you can sometimes see the reflection of the laser beam. So if you've turned on the high def on YouTube, you'll pick that out. So this is the magnet I'm going to put in place. You can see there's a small hook that I'm going to try very unsuccessfully to put through the thread. It's just a standard bar magnet, but you can maybe just make out, there you go, it's got this mirror on it, so the laser is going to reflect strongly off that mirror surface. It's basically just glass, but it will reflect nicely off that. So let's see if I can get that done. Oh god, I hate doing this. We have this little panel at the side, which theoretically at least we can use to access. Genuinely, it takes me about 3 hours to do this. First try. Oh god, I goddamn hate doing that. Okay, so that's the magnet set up in place. You can see I've got some side-to-side oscillation, which I'm going to leave it a minute to steady. But let me just shift the camera. So what you can see here is the laser dots kind of reflecting off. You can see the reason we have this bit of plastic here is so that we can see where the laser beam is if we need to adjust. But you can see by the flashing of this LED that we're getting detection events. So that's really good. We should be pleased by that. So let me adjust so that we can have a look at the actual equipment and do the experiment.